Good morning. You're looking at the notes for proving the similarity of two triangles. Remember that similarity is what you've got if you have two triangles that are the same shape, they have the same angles, but they're not necessarily the same size. But that means that all the sides must be in the same ratio. And that's the first 2 points on these notes. If you can look at two triangles and prove that all of their sides are in the same ratio, then those are similar triangles. They'll be the same shape, just one will be bigger than the other. If you can look at two triangles and show that their angles are equal, then you've also proved that they're similar. They're the same shape, it's just that they're not necessarily the same size. Now, there are two other proofs for similarity that we need to look at. The first one is if we've got two right-angled triangles and if they're right-angled, and the hypotenuse and one other side are in the same ratio. That means we're only interested in two sides of the triangle. Okay, so if you've got two right-angled triangles, like this, and you know this is a 5 and that's a 3, and another one like this, you might know that that's a 9 and that's a 15. You don't need to know the length of this other side down here. You just need to know that 15 divided by 5 is 3 and 9 divided by 5 is 3. That means that the scale factor between these two triangles is 3, and if you applied Pythagoras' theorem, you could work out the other two sides. That would be a 4 there, and that would be a 12. But you don't need to know that in advance. You just need to know that if you've got right-angled triangles, and you have the hypotenuse and one other side in the same ratio, then those triangles will be similar. Similar sort of thing here. You don't need to know all the angles. You only need to know 2 out of the 3, because you can always figure out the third by subtracting from 180. So it's enough to know only 2. Now this is the tricky one. If you've got two triangles where the sides are in the same ratio, so let's go with 3 and 5, and you know the angle in here, that looks about 40 degrees to me, I might be wrong. And you don't know the third side, so I don't know the top side of that. What happens if I don't know, double the size of the triangle, 6 and 10, and I know that's a 40-degree angle there? What do you think is going to happen to this side? Well, the top side will double as well. So it's enough to know that two sides are in the same ratio as long as the angle in between them is equal. It has to be the angle in between the two sides that you know. And that's the notes. So you might like to pause the video here and finish writing that down. Here's the example that we need to prove. Okay? I want to prove that these two triangles, A, B, C, and X, Y, Z, are equal. And if you look at the way I've lettered it, the two sides that I know are AC and BC. Here it's XZ and YZ. So you need to be careful that we are keeping the letters in the same order. Oh my gosh, they're not similar. Let me just change that example so it's a 33 degrees. I didn't pick that up when I drew it. Okay, so if that's a 33-degree angle and that's a 33-degree angle, are those two triangles similar? Let's prove it. So in triangle A, B, C, and triangle X, Y, Z, what sort of proof are we going to use? Well, it's got to be this line number 4. Two sides are in the same ratio and the included angle is equal. Two sides are in the same ratio. Let's prove that. I'm going to look at the ratio of AC to XZ. AC to XZ. Now, AC is 6, XZ is 30. So that's 1/5. Now look at the other two sides, BC and YZ. BC to YZ. BC is 7, YZ is 35, so the ratio is 1 to 5. And it's obvious that ACB and XZY are equal, now that I've changed XZY. So I can just say that angle, that should be ACB is equal to angle XZY. That's given. Don't need reasons for these ones. They're calculations. So given that, we need to say, we can now say that triangle ABC is similar to triangle XYZ because of two sides in the same ratio. Two sides in the same ratio. 11O. And the included angle is equal. Okay, so there's 4 proofs, 4 possible sorts of proofs you need to remember. Those 4, and you need to be able to apply them and write proofs that look like this. Actually, a lot like congruence proofs, so don't be scared of those questions.